Good to see all of you. You see a quote up there by Niels Bohr, one of the founding figures of quantum mechanics. Anyone who thinks they can talk about quantum mechanics without getting dizzy hasn't yet understood the first word of it. Now, why would that be? What did Niels Bohr mean by that? Well, basically he meant that we all have a good intuition for classical physics, right? And by that I mean, if I was to take any little object, right, give it a catch, nice, did a one-handed catch right there, throw this a little bit further back, and we go 2 for 2. No, we're 1 for 2. They're still back in the dark age. Here we go. You have that one over there? Good. Right now, each one of the people who caught, so that would be the 2 of you over here, is a really evolved human being. No, you see, when we were out there in the savannah trying to survive, right, we needed certain skills. We needed to be able to know where to throw a spear, how to throw a rock to get the next meal. We needed to dodge some animal that was running toward us, and therefore we learned the basic physics of the everyday macroscopic so-called classical world. We learned that intuitively. And that's why when I throw an object, you don't have to go through some elaborate calculation to figure out the trajectory of that stuffed animal. You just put out your hand and catch it, right? It's built into our being. But that's not the case when we go beyond the world of the everyday. If we explore the world, say, of the very small, which is what we're going to focus on here tonight, we don't have experience in that domain. We don't have intuition in that domain. And in fact, were it the case that any of our distant brethren way in the past, if they did have some quantum mechanical knowledge, and they sat down to think about electrons and probability waves and wave functions and things of that sort, they got eaten. Their genes didn't propagate, right? And therefore, we have to use the power of mathematics and experiment and observation to peer deeper into the true nature of reality when things are beyond our direct sensory experience. And that's what quantum mechanics is all about. It's trying to describe what happens in the microworld in a way that's both accurate and revealing. And the thing to bear in mind is, even though our focus here tonight will really, in some sense, be in the micro world, the world of particles, we are all collections of particles. So any weirdness that we find down there in the micro world, in some sense, it has an impact even in the macro world, and maybe suppressed, as we'll discuss. But it's not like there's a sharp divide between the small and the big. We are big beings made of a lot of small things, so any weirdness about the small stuff really does apply to us as well.